Welcome to this tutorial in which we'll discuss the main concepts of kinematics, which is a part of physics focused on describing how things move. In order to describe motion, we'll first have to define a few quantities. In this video, I will mostly focus on definitions, on differences between distance and displacement, differences between speed and velocity, and I will also cover definition of acceleration. I will also try to illustrate some of the concepts with simple examples. Before we start talking about kinematics, let's discuss the differences between scalar and vector quantities. Scalars are quantities which only have magnitude and are fully described by a number representing this magnitude. An example of a scalar quantity could be temperature, as it has magnitude, let's say 25 degrees, but it doesn't have direction. Vectors, from the other hand, are quantities which are fully described by both magnitude, numerical value, and direction. To fully describe force, for example, we have to state its magnitude and direction, so force is a vector quantity. I'm sure that you will agree that it makes a difference if something is pushed to the left or to the right. The first two quantities we need to cover in this topic are displacement and distance. We'll start by defining both quantities. Displacement is a vector quantity, and it is defined as the distance moved from a point in a specific direction. Let's imagine an object starting at position di and then moving along a curved path to the final position df. Initial and final positions can be described by two displacement vectors starting from a reference point. Initial and final displacement vectors are shown on the diagram as xi and xf. We could say that the journey started at a certain distance northeast from our reference point and ended at another distance, this time east from our reference point. Change of displacement, which is shown on the diagram by the red arrow delta x, is the difference between the vectors describing final and initial displacements. To calculate the magnitude of the change of displacement, we'll have to use some maths to calculate the length of delta x, which is probably a topic for another video. In this case, let's just say that the change of displacement was 10 km south. Distance, from the other hand, is a measure of how far object moved, and it's measured along a path. Let's assume that the car started at position di with an initial odometer reading of 57,763 kilometers. The car traveled along a curved path to the final position, where the odometer reading was 57,803 kilometers. To calculate the distance in this case, we need to subtract the initial odometer reading from the final odometer reading, which in this case gives us 40 kilometers. Understanding the meaning of words distance and displacement allows us to define speed and velocity, which will help us to describe how things move. Let's start by discussing speed. Speed is defined as the distance traveled per unit time. It is a scalar quantity, so it doesn't have direction. It doesn't matter if an object is moving forward or backward. In both cases, the distance increases. We can use this formula to calculate speed. Speed is measured in meters per second, or it could be measured in other units such as centimeters per second or kilometers per hour. Unit of speed is always a unit of distance divided by a unit of time. In this simple example, we'll learn how to use the formula for speed. First, we'll calculate the distance traveled by subtracting the two readings on the odometer. As we have previously discussed, the distance would be 40 kilometers. To calculate the time taken for the journey, we'll subtract the initial time, which is 9:45, from the final time, which is 10:45, so the total time for the journey was 1 hour. Speed is the ratio of distance traveled and the time taken, so in this case it's just 40 kilometers per hour. In the second example, we'll calculate the distance. Let's start by making a list of information given in the question. Speed is 25 meters per second and time is 3 minutes. Notice that the time was given in minutes, but the unit of time in speed was seconds. We need to make sure that we are not mixing different units of the same quantity, so we'll convert minutes to seconds by simply multiplying 3 by 60, which is 180 seconds. Now we can use our speed formula. We will rearrange it by multiplying both sides by delta t. After plugging in numerical values of 25 meters per second and 180 seconds, seconds cancel out and we end up with 4,500 meters, which is 4.5 kilometers. The next important quantity in this topic is velocity. Velocity is defined as the ratio of displacement and time, and it is a vector quantity. Notice the arrows above some symbols in this formula. These arrows show us which quantities are vectors. The direction of velocity is always the same as the direction of change of displacement. Let's have a quick look at how velocity formula can be applied. This diagram once again shows the situation we have discussed at the beginning of this video. To calculate the velocity, we have to divide the displacement by the time. Let's just assume that the displacement in this case was 10 kilometers and that the object took 1 hour to get from the initial to the final position. Velocity is just 10 divided by 1, which is 10 kilometers per hour. To fully describe the velocity, we should say that the velocity is 10 kilometers per hour south. When we calculated speed and velocity in the previous examples, we actually calculated the average speed and the average velocity. To calculate instantaneous speed or velocity, which is speed or velocity at a given moment, we'll have to use distance traveled or change in displacement in a very short time. If an object is moving along a curved path, to see the distance traveled in a very short time, which could be considered to be an instance, we'd have to magnify a small portion of the path. If the time is short enough, the small part of the path is going to be a straight line. The short straight line will define change of displacement, and since we already know that velocity has the same direction as the change of displacement, velocity will have the same direction as the short line. This means that instantaneous velocity at any given moment is always tangent to the path. So how is velocity actually different from speed? The main difference is that the speed does not depend on the direction in which the object is traveling, but velocity does. Car driving in a circle with a constant reading on the speedometer of 5 km per hour is moving with a constant speed. Although the car is moving at a constant speed, the direction of the car's movement continuously changes, so because velocity is a vector quantity, its velocity changes. In nature, things do not always move at constant speed or in a straight line. In order to be able to describe this kind of motion, we need to define another quantity, which is called acceleration. Acceleration is defined as the change in velocity per unit time. It is very important to note that it is the change in velocity per unit time, not the change of speed per unit time. Acceleration is a vector quantity, and it can be calculated by this formula. To calculate the acceleration, we have to divide the change in velocity by the time taken. So the unit of acceleration is the unit of velocity, which is meter per second, divided by the unit of time, which is second, which gives us meter per second squared, or meter second to the power of -2. Acceleration is a vector quantity, so what is its direction? Direction of acceleration is always the same as the direction of the vector representing the change of velocity. Let's have a look at a simple example of how we can calculate acceleration. A speedboat travels to the east with a velocity of 10 meters per second. The boat takes 1 minute to turn south without changing speed. Calculate the magnitude of the average acceleration during the turn. So there is a boat moving east. The boat then slowly turns south and the turn takes 1 minute. Let's list things that we know in this problem. The boat moves at a constant speed, and it is a common misconception to think that if something is moving at a constant speed, it cannot be accelerating. I hope that you still remember that acceleration was defined as the change of velocity per unit time, not the change of speed per unit time. In this case, although speed is constant, the velocity changes because both changes direction. Since there is a change in velocity, there is acceleration. Let's draw a vector diagram showing both initial and final velocities. To calculate the acceleration, we will first have to calculate the change in velocity. To calculate the change in velocity, we'll subtract the initial velocity from the final velocity, but because velocity is a vector quantity, we'll have to subtract the two vectors shown on the diagram. Subtracting a vector is the same as adding a negative vector, which means a vector in the opposite direction. We'll now add these two vectors to find the change in velocity. Initial and final velocities were at the right angle, so we end up with this right-angled triangle. To calculate the magnitude of the change in velocity, we can use the Pythagoras theorem. Notice that arrows disappeared from our equation. This is because we are now only using magnitudes, which means the lengths of the arrows. In your homework, classwork or exam, you don't really have to draw those arrows above symbols representing vector quantities, but you should always be aware which quantities are vectors and which are scalars. I only drew these little arrows to help you to understand this example. Using the values from our list, we can calculate the magnitude of the change in velocity, which in this case is 14.1 meters per second. Now we can calculate the magnitude of acceleration, which is 14.1 meters per second divided by 60 seconds, which is 0.235 meters per second to the power of -2. Units is the other thing that you don't necessarily have to write when you are solving physics problems, but you must always check if the values you are using in your solution are consistent in terms of units, and if they will give you the answer in the unit expected in a given question. Mistakes related to wrong units being used in solutions are very common, so be careful. Let's finish this video with few final thoughts. Both speed and velocity have two distinct meanings and have two different definitions in physics. Acceleration is a vector quantity based on change of velocity, which is also a vector quantity. So even if an object is moving at a constant speed, it may still be accelerating if direction of its motion is changing. If motion is in a straight line without changing direction, distance is equal to the magnitude of the displacement and speed is equal to the magnitude of the velocity. When we are dealing with vectors, direction is important. When I consider vectors, I usually choose the direction of the initial velocity to be positive. So negative acceleration means that acceleration is in the opposite direction to the initial velocity. This happens when objects slow down. It is worth remembering that negative acceleration is called deceleration. Thank you for watching, and I hope to see you in the next Easy Physics video.